Good Saturday morning, everybody. I just wanted to jump on here and do another wastewater terminology session. This day, I'm going to be doing the F's, the G's, and the H's and terminology in the alphabet. And I just wanted to just say, yeah, I'm very excited. Felt really good. Last night was my birthday, or yesterday was my birthday, my 41st birthday. Celebrated that by going to a Pacer game, and I'm a big Indiana Pacers fan. Been so for years, and this year they're really horrible. They had the worst record in the NBA, or the National Basketball Association, for those that are in a different country. But yeah, anyway, they played the LA Clippers. It was a pretty good game, but they lost in the end by 1 point, and that wasn't great. But all in all, I'm grateful I had a great birthday. Got some good, cool gifts. I got a Reggie Miller jersey from my wife, some hats, a couple a new pair of shoes, and just a really good time. So I'm excited about that, and to share that with you. And maybe one day in the future, I'll actually do a show that kind of digs more into like my life, and especially as my journey as an operator. How did I get to be a Class 1 wastewater operator? How did that all come to be? So I'd like to talk about a little bit about that, and have that to share with you all today. So, but like I said, we're going to start with the F's, and we'll be able to get started. Facultative bacteria. Facultative bacteria can use either dissolved oxygen or oxygen obtained from food materials such as sulfate, nitrate ions. In other words, facultative bacteria can live under aerobic, anoxic, and anaerobic conditions. So, to kind of paint a picture for that, is like if you are like I said, I was talking about sports earlier. So in like football, you would have certain type of players that play different positions on the field, and so you'd have a person that's playing cornerback, but they can also play wide receiver. And I guess to kind of illustrate that, it's like facultative bacteria. It can either be aerobic, which is with air, with oxygen, or it can be anoxic, that has oxygen depletion, or it could even be anaerobic conditions, which that means the presence of no dissolved oxygen. So that's what facultative bacteria does, which will lead us into our next definition, a facultative pond. A facultative pond, this is the most common type of pond in current use in wastewater treatment. The upper portion, or the supernatant, is aerobic, while the bottom layer is anaerobic. Algae supply most of the oxygen to the supernatant. So a facultative pond, that's the most common pond that there is out there. I recommend any of you to look on YouTube at a channel called Operator Mindset. It's a buddy of mine's named Matt, and he explains this very subject very well, and goes through the ins and outs of a facultative pond. If you are interested in more like learning about it and seeing how one looks, and everything. That's a great description. Look up facultative pond and look up operator mindset on YouTube. Filamentous organisms. Those are organisms that grow in a thread or filamentous form. Common types are Thryothrix and Antisemonites, or I probably butchered that word, but it's a common cause of sludge bulking in the activated sludge process. So filamentous bacteria looks like it says, it's like thread-like filaments in the sludge when you're looking at it under a microscope. It looks like a lot of, like you pulled out hair from a hairbrush, and they're very stringy and they're very thread-like, and they don't cause the sludge to settle properly, and it causes it to bulk up in the clarifier. And you'll know that because you'll have low dissolved oxygen, or and probably I think it's a high food to microorganisms ratio, and something like that, to where like the filaments are taking over. So in a system, so you don't want too many of them. You want a little bit in there to get the sludge to compact properly the way it's supposed to be. But for the most part, you don't want these to dominate a system because it'll sludge bulk. Next is a filter aid. A chemical, usually a polymer, added to water to help remove fine colloidal suspended solids. Filter aid. Fixed sample. A sample is fixed in the field by adding chemicals that prevent the water quality indicators of interest in the sample from changing before final measurements are performed later in the laboratory. That was a fixed sample. Fixed spray nozzle. Cone-shaped spray nozzle used to distribute wastewater over the filter media, similar to a lawn sprinkling system. A deflector or steel ball is mounted within the cone to spread the flow of wastewater through the cone, thus causing a spraying action. Also see distributor. So it's a cone-shaped spray nozzle. So it's more, these are like more like talking about like trickling filters, how they have a distributor arm and it goes around this looks like a clarifier, and it sprays wastewater over the bed of rocks or a plastic filter media, so that it can, the biomass and the wastewater and the biology of it will attach to the media or the rocks or the plastic media. It will attach to it and have a zooglio film that is on that media to treat wastewater. Flame polished is melted by a flame to smooth out irregularities. Sharp or broken edges of glass, such as the end of a glass tube, are rotated in a flame until the edge melts slightly and becomes smooth. Flights. Scraper boards made from redwood or other rot-resistant woods or plastic used to collect and move settled sludge or floating scum. Flights. Flock. Clumps of bacteria and particles or coagulants and impurities that have come together to form a cluster, found in flocculation tanks, sedimentation basins, aeration tanks, secondary clarifiers, and chemical precipitation processes. Flock. To speak on that, the particles in water carry a negative charge and the coagulants carry a positive charge, and when they mix together, when the coagulant is dosed in the water, it creates a mixing action, and it creates a flock, which is like a clump, like it says, like a cluster, a clump of a flock of bacteria or whatever it is, and then it clumps it up so it can be able to treat, process that. That happens in water treatment as well as wastewater. So flocculation, this might give you a better picture. It's the gathering together of fine particles after coagulation to form larger particles by a process of gentle mixing. This clumping together makes it easier to separate the solids from the water by settling, skimming, draining, or filtering. Flow equalization system. A device or tank designed to hold back or store a portion of peak flows for release during low flow periods. And then next, this is a big one for, all of these are important for you when you're testing, but this next one, you'll definitely see a lot of things on this when you are testing. So it's very good to note this process. It's called food to microorganisms ratio, or FM ratio. The food to microorganisms ratio is a measure of food provided to bacteria in an aeration tank. And the formula is food divided by microorganisms equals the BOD in pounds per day divided by the mixed liquor volatile suspended solids in pounds. And that you can do that. So it's really how to calculate that to get that the BOD in pounds per day divided by the mixed liquor volatile suspended solids. You will calculate the pounds formula, which is flow in million gallons per day times the BOD in milligrams per liter times 8.34 pounds or gallons, and the 8.34 is a constant. So that's just a constant number that is given in formulas. That's something to remember. But you will take that and you will calculate the pounds of BOD. And then for your mixed liquor volatile suspended solids, you will take the volumes in million gallons a day times your mixed liquor volatile suspended solids in milligrams per liter. You times that by 8.34, and then you'll get the pounds for your mixed liquor volatile suspended solids. And that will give you your food to microorganisms ratio. What the ratio is in the system, how much food that you're giving, how much food, or the BOD, which BOD, that's another way you can, kind of substitute to say food. That's the incoming wastewater. And the mixed liquor volatile suspended solids is a biomass that you have in your system. So that's just a way to calculate it. But anyway, back to carrying on. A force main. That is a pipe that carries wastewater under pressure from the discharge sides of a pump to a point of gravity flow downstream. A force main. Free available chlorine residual. That is the portion of the total available chlorine residual composed of dissolved chlorine gas, hypochlorous acid, and or hypochlorite ion remaining in water after chlorination. This does not include chlorine that has combined with ammonia, nitrogen, or other compounds, also called free available residual chlorine. So next is free chlorine. Free chlorine is chlorine in a liquid or gaseous form, free chlorine combines with water to form hypochlorous and hydrochloric acids. In wastewater, free chlorine usually combines with an amine or ammonia or nitrogen or other organic compounds to form combined chlorine compounds. Free oxygen. Molecular oxygen available for respiration by organisms. Molecular oxygen is the oxygen molecule, O2, that is not combined with another element to form a compound. Freeboard. The vertical distance from the normal water surface to the top of the confining wall. And the second thing about a freeboard is the vertical distance from the sand surface to the underside of a trough in a sand filter. This distance is also called available expansion. So that's what a freeboard is. Friction loss. The head pressure or energy, they are the same, lost by water flowing in a pipe or channel as a result of turbulence caused by the velocity of the flowing water and the roughness of the pipe. Channel walls or restrictions caused by fittings. Water flowing in a pipe loses head pressure or energy as a result of friction losses, also called head loss. All right. So we're on the G's now, and we're going with gasification. The conversion of soluble and suspended organic materials into gas during aerobic or anaerobic decomposition. And clarifiers, the resulting gas bubbles can become attached to the settled sludge and causing large clumps of sludge to rise and float on the water surface. In anaerobic sludge digesters, this gas is collected for fuel or disposed of a waste gas burner. And gasification, they're alluding to denitrification, when those gas bubbles become attached to settled sludge, and then it causes large clumps to rise and float on the water surface. When you have denitrification in a system. Geographic Information System, or GIS, a computer program that combines mapping with detailed information about the physical locations of structures such as pipes, valves, manholes within geographic areas. The system is used to help operators and maintenance personnel locate utility system features or structures, and to assist with the scheduling and performance of maintenance activities. GIS. And there's a lot of good GIS systems out there. Hopefully your utility uses GIS. But they have some very good ones out there to look at. A grab sample is a single sample of water collected at a particular time and place that represents the composition of the water only at that time and place. So a grab sample is not to be confused with a composite sample, as we did in one of our last sessions. A grab sample is just for that moment in time, a single sample for that moment in time. A composite sample is multiple. How I would explain it is like multiple grab samples that's over a period of like 24 hours, and then it's collected as a representative of a sample. So one big sample with many samples in it is a composite, but a grab is just one. And how to describe a grab sample, it would be like you grab a pH sample, you can grab a total coliform sample, or a chlorine residual, and all of those samples are grab samples because they should be taken and they should be administered at least within 15 minutes. After 15 minutes, the sample is probably no good and you need to retest it again to get an accurate number. So that's what a grab sample is. Gravimetric, a means of measuring unknown concentrations of water quality indicators in a sample by weighing a precipitate or residue of the sample. Gravimetric. Grit, the heavy mineral material present in wastewater such as sand, coffee grounds, eggshells, gravel, and cinders. Also called detritus, but it's grit. Next is a grit chamber. Is a detention chamber or an enlargement of a collection line designed to reduce the velocity of flow of the liquid to permit the separation of mineral solids from organic solids by differential sedimentation. It's a grit chamber. And then a grit channel has several definitions, but the first is an enlargement in a collection line where grit can easily settle out of the flow. And the second one is the waterway of a grit chamber. Grit collector, a device placed in a grit chamber to carry deposited grit to a point of collection for ultimate disposal. Grit collector. Grit compartment, the portion of the grit chamber in which grit is collected and stored before removal. Grit removal. Grit removal is accomplished by providing an enlarged channel or chamber that causes the flow velocity to be reduced and allows the heavier grit to settle to the bottom of the channel where it can be removed. So, because when you got it, the wastewater coming in the collection system is usually, I think they said like 2 feet per second or 2.5 feet per second, and that's when it's coming in to the plant. And then when it comes into the plant, then the flow is slowed down to 1 feet per second so that grit can settle out, because you don't want grit to get into the downstream processes of a wastewater treatment plant, because there's pumps and there's other clarifiers and tanks and things, and that grit can settle in there. And especially for the pump's sake, you don't want that to happen because they wear down and they're really abrasive on pumps. The grit is, so you want that to settle out early on in the process so it's not being very costly on you if you don't get it removed. A grit tank is a structure located at the inlet into a treatment plant for the accumulation of and removal of grit. Grit trap, a permanent structure built into a manhole or other convenient location in a collection system for the accumulation and easy removal of grit. Growth rate, an experimentally determined constant to estimate the unit growth rate of bacteria while degrading organic waste. And finally, we're gonna get on the H's. We got a little bit here, and then we'll be wrapping it up. But we're gonna start with a harmful physical agent or toxic substance. That is any chemical substance, biological agent, which is a bacteria, virus, or fungus, or physical stress, which is noise, heat, cold, vibration, repetitive motion, uh, ionizing, non-ionizing radiation, hypo or hyperbaric pressure. That is one that is regulated by any state or federal law or rule due to a hazard to health. 2, it is listed in the latest printed edition of the National Institute of Occupational Safety and Health Registry of Toxic Effects of Chemical Substances, or RTECS. 3, has yielded positive evidence of an acute or chronic health hazard in human, animal, or other biological testing conducted by or known to the employer. And 4, is described by a material safety data sheet available to the employer that indicates that the material may pose a hazard to human health. Head. The vertical distance, height, or energy of water above a reference point. A head of water may be measured in either height, feet, or meters, or pressure, pounds per square inch, or kilometers per square centimeter. Head loss. The head pressure or energy, they are the same, lost by water in a flowing pipe or channel as a result of turbulence caused by the velocity of flowing water and the roughness of the pipe, channel walls, or restrictions caused by fittings. Water flowing in a pipe loses head pressure or energy as a result of friction losses. The head loss through a filter is due to friction losses caused by material building up on the surface or in the top part of a filter. So we said that in the last one, couple letters ago. Friction loss and head loss are similar in definition. Header, a large pipe to which the ends of a series of smaller pipes are connected, also called a manifold. Headworks, the facilities where wastewater enters a wastewater treatment plant. The headworks may consist of a bar screen, comminutors, a wet well, and pumps. And as I said before, especially about grit, you want you to have a good system of headworks when the wastewater is coming into the plant, because you don't want that grit to go past that and get into your pumps and tanks, and it'll cause you a lot of headaches. Hepatitis is an inflammation of the liver caused by an acute viral infection. Yellow jaundice is one symptom of hepatitis. Humus sludge, the sloughed particles of a biomass from a trickling filter media that are removed from the water being treated in the secondary clarifiers. Hydraulic grade line, the surface of profile of water flowing in an open channel or a pipe flowing partially full. If a pipe is under pressure, the hydraulic grade line is that level water will rise to in a small vertical tube connected to the pipe. Take a drink real quick. So, hydraulic jump is the sudden and usually turbulent, abrupt rise in water surface in an open channel when water flowing at a high velocity is suddenly retarded to a slow velocity. Hydraulic jump. Hydraulic loading. Hydraulic loading refers to the flows in million gallons a day to a treatment plant or treatment processes. Detention time, surface loadings, and where overflow rates are directly influenced by flows. Definitely when you're studying for your exam and studying to get all this stuff in your mind, that's something that you will have to brush up on your math is these hydraulic loading rates, these surface loading rates, weir overflow rates, because they can test you on any of that stuff. Hydrogen ion concentration. The weight of hydrogen ion in moles per liter of a solution, commonly expressed as the pH value, which is a logarithm of reciprocal of the hydrogen ion concentration. So in math terms, it's pH equals log, and then 1 over H plus. Hydrogen sulfide gas. Hydrogen sulfide is a gas with a rotten egg odor produced under anaerobic conditions. Hydrogen sulfide is particularly dangerous because it dulls the sense of smell, becoming unnoticeable after you've been around it for a while. In high concentrations, it is only noticeable for a very short time before it dulls the sense of smell. The gas is very poisonous to the respiratory system, explosive, flammable, colorless, and heavier than air. So you would definitely encounter this in the wastewater treatment plant, or it could be in the collection system, especially in manholes when people got to go down there and work and do things. You have to get a confined space permit to go down into these manholes and different types of vaults and stuff, because if it's got this stuff in there, like I said, you can smell it for a little while, but after it stops, it's very dangerous. It can kill you. It's heavier than air, so it's in the same respect like chlorine is going to settle at the bottom of the ground or the floor, because it's heavier than air. Next is hydrologic cycle. It's the process of evaporation of water into the air, and it returns to the earth by precipitation, rain or snow. This process also includes transpiration from plants, groundwater movement, and runoff into rivers, streams, and the ocean, also called the water cycle. And definitely on the water treatment side of things and taking an exam, that is something that's very important to know, is the hydraulic cycle. So you definitely need to know that. Hydrolysis. It is a chemical reaction in which a compound is converted into another by another compound taking up water. Usually a chemical degradation of organic matter is hydrolysis. Hydrostatic system. In a hydrostatic sludge removal system, the surface of the water in the clarifier is higher than the surface of the water in the sludge well or hopper. The difference in pressure head forces sludge from the bottom of the clarifier to flow through the pipes to the sludge well or hopper. Hygroscopic. Absorbing or attracting moisture from the air. Hyperchlorination is the application of hypochlorite compounds to water or wastewater for the purpose of disinfection. Hyperchlorinators are chlorine pumps, chemical feed pumps, or device used to dispense chlorine solutions made from hypochlorites such as bleach, sodium or that's sodium hypochlorite, or calcium hypochlorite in the water being treated. And then hypochlorite, is chemical compounds containing available chlorine used for disinfection. They are available as liquids or bleach or solids, powder, granules, or pellets in barrels, drums, and cans. Salts of hypochlorous acid. And so that's what I have for you. That's about close to 35 minutes of some good studying to reinforcing your brain and to have you to put this in your study notes and everything. Is learning this terminology is very important. It gives you a clear picture of how wastewater treatment is administered and done, and helps you to learn more. So, as I said, I probably will be releasing like 3 of these in a row, probably on the same day, just to get them going, so I can kind of let you guys know that, build up the channel. Or I wouldn't say channel, but build up the podcast to get this out there so people can study and learn. Like I said, it's some of this is specific to Indiana, which is the regulations part of it. But for the most part, wastewater is wastewater. So, a hypochlorinator, just what I just said, is a hypochlorinator. Inorganic waste is inorganic waste, or whatever. Those things don't change, but regulations and rules, they kind of change from state to state. So, but like I said, I'm about to jump off here and get to celebrating the rest of my birthday weekend. Like I said, I would love to do a podcast show on just my background as an operator and the things that I'm learning today and how I'm growing and, other kind of types of things. So just want to let y'all know that. I hope y'all have a great, wonderful day, and see you on the next side.